Very good morning to all of you. Today I want to conduct Module 4 class of Session 5. Title of Module 4 is Bearing Capacity of Shallow Foundation. The course outcome of Module 4 is ability to determine bearing capacity of soil and achieve proficiency in proportioning shallow, isolated and combined footing for uniform bearing pressure. So this is the outcome comes from Module 4. Title of subject is Applied Geotechnical Engineering. Subject code is 18 CV 62 in 6th semester of Civil Engineering departments. Let us see, today I want to solve some different numerical problems based on last session 1 to session 4 discussions. Okay, how problems are asked and how to solve the problems. Okay, let us see example. First, a square footing 2 meter by 2 meter is built in a homogeneous bed of sand of density 1.9 ton per cubic meters and having an angle of shearing resistance of 38 degree. The depth of the base of the footing is 0.8 meter below the ground surface. What is the safe load according to the Terzky analysis which can be carried by the footing with a factor of safety of 3 against complete shear failure? This is the problems. Okay. Let us follow the same steps. Solution. Given data. Here you write which are the data are given in problems. B is 2 meter, DF is 0.8 meter given, gamma is 19 kilonewton per cubic meter, phi is 38 degrees given, Fs is 3. Then to find safe load, how much, and safe bearing capacity equal to how much. Procedures. So first you draw the diagram as per the given data. So this is the footing of depth 0.8 meter and width is 2 meter by 2 meter size, and unit weight of soil is given of the foundation soil is 19 kilonewton per cubic meter. So this is the diagram based on the given problems. Okay. Let us see, follow the steps. First step, ultimate bearing capacity for square footing is given by the following equations. That is Q equal to 1.3 times CNC plus gamma df nq plus 0.4 times B gamma n gamma. This is for sandy soils, C is 0. So then you determine bearing capacity factor nq equal to tan square of 45 plus pi by 2 into e raised to pi tan phi. Now substitute the value in these empirical equations. Phi is 38. Now you solve these equations. While solving these equations, we are getting nq is 48.93. Now calculate n gamma equal to 1.8 times nq minus 1 into tan phi. This is the empirical equation. Now substitute the value here. Here nq is 48.93 and phi is 38 degree. So then while solving this equation, so n gamma we are getting 67.4. Now substitute the value in step 1. Therefore Q equal to 1.3 times C and C. This is the equations written. Then you substitute the value. Here C becomes 0 means first part is 0. Okay. Next here gamma is 19 into DF is 0.8 into NQ is 48.93 plus 0.4 into B is 2 into gamma is 19 into N gamma is 67.4. Now while solving these equations we are getting answer is 1768.35 kilonewton per meter square. This is the ultimate bearing capacity. Then step number 2, net ultimate bearing capacity, that is QNU is given by the following equation. QNU equal to QU minus gamma into DF. Now substitute the value in this equation. Here QU is 1768.35 minus gamma is 19 into DF is 0.8. We are getting 1753.155 kilonewton per meter square. This is the net ultimate bearing capacity. Then now calculate net side bearing capacity. QNS is given by the concept QNU by factor of safety. So here QNU is 1753.155 divided by factor of safety is 3. So now answer is 584.38 kilonewton per meter square. This is the net side bearing capacity. Then you calculate side bearing capacity. QS is given. QS equal to QNS plus gamma into DF. That is overburden pressure. Now substitute the value in these equations. QNS is 584.38 plus gamma is 19 kilonewton per meter cube into DF is 0.8. We are getting 599.58 kilonewton per meter square. This is the safe bearing capacity. Then you calculate maximum safe load P. We know SBC equal to load by area. So then load equal to area into SBC. So therefore area is 2 by 2 meter, that is 2 into 2 into SBC is 599.58. We are getting answer is 2398.32 kilonewton. So this is the maximum safe loads acting on this size of the foundations. So this is the complete solution of this type of problems. Let us see next problems. What will be the gross net bearing capacity of sand having angle of internal friction 36 degree and dry unit weight of sand is 19 kilonewton per cubic meter for the first case 1.5 meter wide strip foundation, second case 1.5 meter by 1.5 meter square footing. So these are the two conditions. The footings are placed at a depth of 1.5 meter below the ground level. Take factor of safety as 2.5. Use Tersky bearing equations. So here with respect to phi value, Tersky's bearing factor is given in table. So with respect to phi, so for 35 degree NC is 57.8, NQ is 41.4, N gamma is 42.4, and for 40 degree NC is 95.7, NQ is 81.3, N gamma is 100.4. So this is the clear asked the problems. So in this problem how to solve, let us see. Okay, follow the same steps. First you write given data. Here phi is 36 degree, gamma is 19 kilonewton per cubic meter, and 1.5 meter wide strip footing is given. Next 1.5 by 1.5 meter square footing is given, and the depth of foundation is 1.5 meter is given. Factor of safety is 2.5 is given. So then to find QS equal to how much, that is safe bearing capacity for strip footing, and second parameter QS equal to how much for square footings. So that means now you solved safe bearing capacity for strip footing as well as safe bearing capacity for square footings. So this is the diagram for given problems. So this is the ground level, this is the depth of the footing is 1.5 meter and size is 1.5 meter width, and unit weight of soil is gamma 19 kilonewton per meter cube. So this is the sketch based on the given data. Now first case for strip foundations, how to calculate SPC. So follow the same steps. So here first step, ultimate bearing capacity for strip footing, this is not square, you make corrections. For strip footing is given by the following equations, that is Q equal to 1.3 times CNC plus gamma DF NQ plus 0.5 times B gamma N gamma. So this is for strip footings equation. Now substitute the value in these equations. So here C is 0, NC is 77.8 based on the phi value. Okay. plus gamma is 19 into df is 1.5 into nq is 61.4. So this value you interpolate from the tables, plus 0.5 times b is 1.5 and gamma is 19 and n gamma is 62.4. So these value obtained from table. So after solving these equations, we are getting ultimate bearing capacity 2639.1 kilonewton per meter square. This is the ultimate bearing capacity. Then next step, you calculate net ultimate bearing capacity is given by the equations QNU equal to QNU minus gamma df. So substitute the value here. Ultimate bearing capacity minus gamma is 19 into df is 1.5. We are getting 2610 kilonewton per meter square. The net safe bearing capacity is given QNS equal to QNF by factor of safety. So now substitute the value in these equations. That is QNS is 2610, QNF is 2610.6 divided by factor of safety is 2.5. We are getting answer is 1044.24 kilonewton per meter square. Next, you calculate safe bearing capacity QS is given by the relation QS equal to QNS plus gamma into df. So here QNS is 1044.24 plus gamma is 19 into df is 1.5. Answer we are getting 1072.74 kilonewton per meter square. This is for strip footing. Safe bearing capacity is this much in kilonewton per meter square. Now you solve in second case, that is for square footings. In second case, for square footing, follow the same steps. Okay, so ultimate bearing capacity for square footing is given by the following equations. That is Q equal to 1.3 times C N C plus gamma df nq plus 0.4 times b gamma n gamma. So now substitute the value here. Okay, C is 0 into NC is 77.8 plus gamma is 19 into df is 1.5 into nq is 61.4 plus 0.4 into gamma is 19 into b is 1.5 into n gamma is 62.4. So while solving these equations, we are getting ultimate bearing capacity 2461.26 kilonewton per meter square. So then next step, we calculate net ultimate bearing capacity is given by the following equations. QNU equal to QU minus gamma into df. So here ultimate bearing capacity 2461.26 minus gamma is 19 into df is 1.5. We are getting 2432.76 kilonewton per meter square. Next, net safe bearing capacity is given by the relation QNS equal to QNU by factor of safety. So now substitute the value in these equations. QNU, that is 2432.76 divided by factor of safety is 2.5. So we are getting 973.10 kilonewton per meter square. This is the net safe bearing capacity. So then calculate safe bearing capacity is given by the equation QS equal to QNS plus gamma into df, that is net safe bearing capacity plus overburden pressure. Now substitute the value in this equation. QNS is 973.104 plus gamma is 19 into df is 1.5. While solving this equation, we are getting 1001.604 kilonewton per meter square. So this is the complete solution of these two type of footings. Next problems. A strip footing 1 meter wide at its base is located at a depth of 0.8 meter below the ground surface. The properties of the foundation soil are gamma is 18 kilonewton per meter cube, C is 30 kilonewton per meter square and phi is 20 degree. Determine the safe bearing capacity using a factor of safety of 3. Use Tersky analysis. Assume that the soil fails by local shear. Okay, so this is another type of problems. Okay, same, follow the steps. Solution: write your given data first. So B is 1 meter, df is 0.8 meters, gamma is 18 kilonewton per meter cube, C is 30 kilonewton per meter square, phi is 20 degree, factor of safety is 3 is given. Okay, so according to these data you draw the diagrams. So this is ground levels and this is the depth of the foundation 0.8 meter and width of the footing is 1 meter and unit weight of soil of this foundation soil is gamma 18 kilonewton per meter cube. Procedure. Okay, ultimate bearing capacity for strip footing is given by the following equations. Q equal to 2/3 C NC dash plus gamma df NQ dash plus 0.5 times B gamma N gamma dash. This equation is based on local shear failure. So local shear failure we are considering phi is less than 28 degree. Okay, where NC dash, NQ dash and N gamma dash values obtained from table 4.1 page 134 by SP Brahma, or you select any textbooks. So from the tables we are getting NC dash, NQ dash, N gamma dash with respect to phi value. Okay, so phi dash we are calculating 2/3 of phi. So theory class we have already discussed. Same with respect to phi dash you select the values from the tables. Therefore NC dash equal to 11.8 we are getting, and NQ dash we are getting 3.9 and N gamma dash we are getting 1.7 from the tables. Therefore substitute the value in ultimate bearing capacity equations. Q equal to 2/3 of C is 30 into NC dash is 11.8 plus gamma is 18 into B is DF is 0.8 into NQ dash is 3.9 plus 0.5 times gamma is 18, B is 1 meter into N gamma dash is 1.7. So answer is 307.46 kilonewton per meter square. Next step, the net ultimate bearing capacity is given by the following equation, that is QNV equal to QEO minus gamma into DF. Here QEV is 307.46 minus gamma is 18 into DF is 0.8. So while solving this we are getting answer is 293.06 kilonewton per meter square. Next step we solve. Net set bearing capacity is given by the equation QNS equal to QNU by factor of safety. Here 293.06 divided by factor of safety 3, so we are getting answer is 97.686 kilonewton per meter square. So then calculate safe bearing capacity by this relation. QS equal to QNS plus overburden pressure, that is gamma into DF. Now substitute the value in this equation. QNS is 97.686 plus gamma is 18 into DF is 0.8. We are getting 112.08 kilonewton per meter square. This is the SBC for strip footings. Next problems. Determine the safe bearing capacity of a square footing 2 meter by 2 meter placed at a depth of 1.2 meter in a soil with a moist unit weight of 17 kilonewton per cubic meter. C is 20 kilonewton per meter square and phi is 20 degree. Take NC dash equal to 11.8, NQ dash equal to 3.9 and N gamma dash equal to 1.7. What is the change in safe bearing capacity if the water table rises to ground level? Assume factor of safety equal to 3. So this is also this type of problem, but this is based on water table also. Okay. First you write the given data. Size of footing is given 2 meter by 2 meter. Depth of footing is given 1.2 meter. Saturated unit weight is given 17 kilonewton per cubic meter. C is given 20 kilonewton per meter square. Phi is given 20 degree. And bearing capacity factor is given NC dash is 11.8, NQ dash is 3.9 and N gamma dash equal to 1.7 and factor of safety is given 3. Then to find, in first case, safe bearing capacity QS equal to how much, and in second case QS equal to how much, that is safe bearing capacity equal to how much if water table at ground level. So this is the complete details given data. Now follow the procedures. So in first case, draw the diagram as per the given data in first case. So this is the ground level, this is the depth of the foundation is 1.2 meter and the size of the footing is 2 meter and saturated unit weight of soil is 17 kilonewton per cubic meters. Okay. And now write first step. Solve ultimate bearing capacity for square footing is given by the following equations. That is Q equal to 2/3 C NC dash plus gamma df into NQ plus 0.4 times B gamma N gamma dash. This is for local shear failures if phi is less than 28 degree. So then substitute the value in these equations. Okay. So 2/3 into C is 20 into NC dash is 11.8 plus gamma is 17 into df is 1.2 into NQ dash is 3.9 plus 0.4 into B is 2 meter, gamma is 17, N gamma dash is 1.7. So answer is 260.01 kilonewton per meter square. This is the ultimate bearing capacity. Now second step, net ultimate bearing capacity is given by the following equations. QNU equal to ultimate bearing capacity minus overburden pressure. Now substitute the value in this equation. We are getting 239.61 kilonewton per meter square. Then next you calculate net safe bearing capacity. QNS is given by the equation QNU by factor of safety. So therefore QNU is 239.61 divided by factor of safety is 3. So we are getting the answer is 79.871 kilonewton per meter square. So then now you calculate safe bearing capacity. QS is given net safe bearing capacity plus overburden pressure. Substitute the value in this equation. We are getting 100.27 kilonewton per meter square. This is the safe bearing capacity for without water tables. Now solve second case. If water table at ground levels, so means draw the same diagram but here locate the water table at the ground surface. So then how to calculate SBC? Let us see. Follow the procedures same. Ultimate bearing capacity for square footing is given by the following equations. That is same equation above. 2/3 C NC dash plus gamma df into NQ dash into RW1 plus 0.4 times B gamma N gamma dash into RW2. Here RW1 and RW2 are special parameters comes for water tables case, where RW1 is calculated by these relations 0.5 times 1 plus ZW1 by D. So now substitute the value here. 0.5 times 1 plus ZW1 is 0 because water table at the ground surface. D is 1.2. We are getting 0.5, that is RW1. Calculate RW2 equal to 0.5 times 1 plus ZW2 by B. Now substitute the value here. 0.5 times 1 plus ZW2 is 0. B is 2, so we are getting answer is 0.5. So this is water reduction factors. Now substitute the value in these equations. That is 2/3 of C is 20 into NC dash is 11.8 plus gamma is 17 into B is depth of the footing is 1.2 and NQ dash is 3.9 into RW1 is 0.5 plus 0.4, B is 2 meter into gamma is 1.7 and 17 into N gamma dash is 1.7 into RW2 is 0.5. So while solving these value, we are getting answer is 203.91 kilonewton per meter square. So then second step, net ultimate bearing capacity is given by the following equations. That is net ultimate bearing capacity equal to ultimate bearing capacity minus gamma into df. Now substitute the value here. So we are getting 183.513 kilonewton per meter square. Next step, we calculate net safe bearing capacity is given by the equation net ultimate bearing capacity divided by factor of safety. Now we are getting answer is 61.17 kilonewton per meter square. Then you calculate safe bearing capacity equal to net safe bearing capacity plus overburden pressure. So net set bearing capacity is 61.171 plus gamma is 17 into df is 1.2. We are getting 81.57 kilonewton per meter square. This is the complete solution of this water table case. Okay, so now here all of you remember, draw the diagram and follow the steps, substitute the value, finally we are getting required value. Let us see these problems. Determine the shape bearing capacity of a square footing 2.1 meter into 2.1 meter placed at a depth of 1.5 meter in a soil with a moist unit weight of 17 kilonewton per meter cube. C is 15 kilonewton per meter square, phi is 20 degree. Take NC dash equal to 11.8, NQ dash equal to 3.9 and N gamma dash equal to 1.7. What is the change in shape bearing capacity if the water table rise to 0.5 meter above footing? Assume factor of safety equal to 3. I think this is also similar steps, but here water table is rise 0.5 meter above the base of the footing. So then you follow the same steps. Okay, so first you write given data. Size of footing is given 2.1 meter by 2.1 meter. Depth of footing is given 1.5 meter. Saturated unit weight, gamma saturated is given 17 kilonewton per meter cube. C is given 15 kilonewton per meter square. And phi is given 20 degree. And bearing capacity factor values are given. NC dash is 11.8, NQ dash is 3.9 and N gamma dash are 1.7. So then factor of safety is given 3. To find first case shape bearing capacity equal to how much, and in second case shape bearing capacity is how much if water table above footing base. Okay, follow the same steps of above problem solved. Okay, slight change here in water tables. First case, draw the diagram. This diagram is based on the given data. Depth of the footing is 1.5 meter and width of the footing is 2.1 meter and unit weight of soil is 17 kilonewton per cubic meters. Now follow the steps. So in the first step, ultimate bearing capacity for square footing is given by the following equations. That is QE equal to 2/3 C NC dash plus gamma df NQ dash plus 0.4 times B gamma N gamma dash. So this equation is based on local shear failure. Okay. Now substitute the value in these equations. Okay. So we are getting answer is 241.726 kilonewton per meter square. In second step, calculate net ultimate bearing capacity is given by the following equation. That is QNU equal to QU minus overburden pressure. So while substituting values, so we are getting 216.226 kilonewton per meter square. Then net shape bearing capacity is given by the equations net ultimate bearing capacity divided by factor of safety. Now substitute the value, finally we are getting 72.07 kilonewton per meter square. Then now you calculate shape bearing capacity is given by the relation net shape bearing capacity plus overburden pressure, that is gamma into df. Substitute the value here, finally we are getting 97.27 kilonewton per meter square. This is the shape bearing capacity without water tables for local shear failure conditions. Come to second case. If water table at ground levels, means draw the diagram here. If water table is below the ground levels, okay, above the base of the footings at 0.5 meter. See here, 0.5 meter above the footings. So then ZW1 is 1 meter below the ground levels and width of the footing is 2.1 meter. Gamma is given 17 kilonewton. Here slight change is only water table locations. This diagram is most important. Now write the equation once again. Ultimate bearing capacity for square footing is given by the following equations. That is QE equal to 2/3 C NC dash plus gamma df NQ dash into RW1 plus 0.4 times B gamma N gamma dash into RW2. So now here in this equation you calculate first water reduction factors. Rw1 is given 0.5 times 1 plus Zw1 by D. So then substitute the value in this equation, we are getting 0.833. And Rw2 equal to 0.5 times 1 plus Zw2 by B. So now substitute the value in this equation. Here Zw2 is 0, B is 2, we are getting answer is 0.5. So then substitute the value in above equations, that is ultimate bearing capacity. So 2/3, C is 15, into NC is 11.8, plus gamma is 17, B is 1.5, dF into NQ is 3.9, okay. So plus 0.4 times gamma is 17, B is 2.1 meter, N gamma dash is 1.7, and water reduction factor Rw2 is 0.5. So now we are getting answer is 212.979 kilonewton per meter square. So here 0.833 and 0.5 are the water reduction factor Rw1 and Rw2. So finally we are getting 212.97 kilonewton per meter square. Then next step, as usual, net ultimate bearing capacity is given by the equation ultimate bearing capacity minus overburden pressure. Now substitute the value, we are getting answer, that is 187.47 kilonewton per meter square. So the net safe bearing capacity equal to net ultimate bearing capacity divided by factor of safety. Now substitute the value, so we are getting here factor of safety is 3, so we are getting 62.49 kilonewton per meter square. So then calculate safe bearing capacity QS equal to net safe bearing capacity plus overburden pressure. So now substitute the value here. Here net safe bearing capacity is 62.49 plus gamma is 17 and dF is 1.5. Finally we are getting 87.99 kilonewton per meter square. This is the SBC for water tables above the base of the footing 0.5 meters. So this is the complete solution of this type of problems. So these are the references are referred for session 5 to solve the different type of problems, okay, with different textbook, different papers, different ACE codes, etc. Thank you, one and all.